Welcome you Larrys. So today we're working on another pure maths question, and this one is using our understanding of circular measure. This is a bit of a doozy. It's a little bit tricky, so you may have had trouble with this when you're trying to do it on your own. So we have this sector of a circle. It's got a centre at O. There is our centre, and then its radius is 20. You can see that. And a circle with centre C lies within the sector, and it touches at three places, P, Q and R. And the angle POR is 1.2 radians. And we first of all have to figure out what x is. Well, x is the radius of this smaller circle here. So how I'm going to go about doing this is I'm going to draw a little triangle here, and then from there to there. And I'm going to use my knowledge that a circle, this OR is a tangent to the circle with centre C, and that means that line CR, the radius that meets the tangent, is at right angles to it. So we've got a right angled triangle here. OCR is a right angled triangle. And therefore I can say that this little angle here is 0.6 radians. Make sure your calculator is set to radians for this, of course. So let's get into this. Let's say we've got sine 0.6 is equal to opposite, which is x, over OC, which again I don't know, it's got x in it. But I can get x by itself here, you see. So I can say, therefore, OC is equal to x over sine 0.6. We're going to have to use a little bit of algebra here to help us. Now the next thing I know that this length here, from O all the way up here, I know that that must be 20. Why do I know that? Because the radius of this larger circle, which we've got a sector of, is 20. So I know that OQ is equal to 20. But I also know that it's made up of OC plus x. Hope you can see that. OC from the bottom here to the centre of the circle, the smaller circle, and then x is from C to Q. Now, therefore we can write in our next step 20 is equal to, now we've got OC over here, so it's going to be equal to x over sine 0.6 plus x. And at this point I'm going to factorise, so I'm going to go 20 is equal to x into 1 over sine 0.6, dear oh dear, plus 1. And then I will get x by itself. X is equal to 20 and over 1 over sine 0.6 plus 1. Now when I chuck that into my calculator, I get an answer of 7.218, etc. And I'm going to save my unrounded number into my calculator because I may need this later on. So I think that was the tricky bit in this question. The rest of it isn't so difficult. Okay, just a little tip here with exam technique. Notice how it says show that x equals 7.218. Perhaps you can't manage to solve that part of the question. But the very fact that they're saying show that means you can actually use that in parts 2 and 3, even if you couldn't do part 1. So just be aware of that as well. So having saved my answer into my calculator, I can now move on to the next part of the question. So what are we going to do here? Part 2. Okay. Find the total area of the 3 parts of the sector lying outside the circle. So in other words, what are they asking from us here? Well, they want us to find this area here, plus this area here, plus this area here. Okay, so hopefully you can see that the area that we want, shaded area, will be equal to the area of the big sector. Subtract from that the area of the circle. So let's do that. Well, the area of the sector, using our formula, is half r squared theta. That's our formula. And the area of a circle is pi r squared. Now, half r squared theta, it's half, times 20 squared, because that's the radius of the big sector. And theta is 1.2 radians, so times 1.2. And we're going to subtract from that the area of the little circle with the centre at C. So that's going to be r squared, in this case, is x. So what do we say? 7.218, etc. Use your unrounded number, squared pi. And when you chuck this into your calculator, you can have a try of that. I'm getting 76.3 centimetres squared, and that's to 3SF. So 3 significant figures. Okay, I hope that makes sense to you. The final question is to find the perimeter of the region OPSR bounded by the arc PSR and the lines OP and OR. So we are trying to find this this perimeter here. So from here all the way down there to O, and then from O to R, and then around this arc of the circle here. So that is what we're trying to find. So what we might want to do first is find what OR is, or OP is. Now, we can think in terms of our triangle that we drew earlier for this, can't we? So if we've got a triangle like this, what do we know? Well, we want to know OR. That's what we want to find. So how are we going to find that? Well, we know that this angle here is half of 1.2, so it's 0.6 radians. And we know CR is x, we've already found that out. So we could use tan, couldn't we? We could say tan 0.6 in radians is equal to the opposite, which is CR, which we know to be 7, what have we found it out to be, 2.218, etc., all over OR. We rearrange. So OR must equal 7.218 all over 10 0.6. Okay. We're going to need 2 of those because we've got OR and we've got OP. So we're going to need 2 of those. And then the other part is this arc here. Now, using our formula for arc length, what do we know? Well, arc length is equal to R times theta. In this case, we know R is equal to 7.218, as we've found out earlier. But we need to figure out what theta is, and for that it will be helpful for us to sketch in the quadrilateral PCRO. We need to find the angle PCR, but what we can do to help ourselves is look at this quadrilateral. We know that angle P is a 90-degree angle, and also R is a 90-degree angle, or should I say pi over 2. And that means that angle C and angle O must add up to pi as well, since all angles in the quadrilateral must add to 2 pi. So angle PCR, once we subtract P and R from the quadrilateral, must be pi, subtract angle POR, which is 1.2. So when we think about the perimeter of this red shape that we've sketched in, it's going to be 2 times 7.218 all over tan 0.6, which gives us PO and OR, the straight parts, straight sides. And then we're going to add to that 7.218 in brackets pi minus 1.2, which will give us the curved arc. And then when I chuck that into my calculator, I'm getting 35.1 centimeters. So this is to 3 significant figures. Well, I hope this makes sense to you guys. It is a bit of a tricky one, that's for sure. But keep on persevering. And I think this is the last pure maths question that we're doing together. We'll be moving on to stats in the next video for you guys. Alright, take care.